Welcome to some homework discussion about the 3.2 section. What I have opened up right now is the actual homework that you'll be accomplishing, and I thought it would be good just to have a video that shows how that feels as you go through here and you work through these truth tables that we're learning through here in section 3.2. And so they'll use the symbols a lot. We want to make sure that you remember these symbols. This little V-looking symbol, the arrow pointing down, that is the OR symbol. And so let's see what our options are. And it says the blank P or Q is false only if. And so it is a conjunction. A conjunction puts two things together. Actually, it's not a conjunction, it's a disjunction, right? And so it's a disjunction because they don't have to both be true in order for it to be true. And so it's only false if P is false and Q is false, sorry. That's the only way an OR statement is going to be true, because if one of the conditions is satisfied, then the whole thing is satisfied. And it's a final check, and it's going to tell us fantastic. And then it's going to ask the same thing about the AND one, right? And so as we go to the AND one is what they call a conjunction. I don't know if I mentioned that in the video or not. A conjunction means that it's only going to be true if they're both true. And so make sure you grab the right ones, but the AND statement is only true if both conditions are met. And so we'll check that as well. And just kind of go through here and see what these are like. You know, fill in the blank to complete the sentence below. This statement is true because, and then you'll have some choices there. I think that one's pretty obvious. Now, here we go with the negation of P or Q. If the negation of P or Q is true, what must both of the truth values of the component statements be? Well, we can think about what the truth table looks like for an OR, and the truth table for an OR statement, right, the one with the downwards facing arrow, they're going to be false. Well, it only, like we mentioned before, P or Q is going to be false if both the P and Q are false. And so we want the negation of P or Q to be true, so we want P or Q to be false. If P or Q is false, then the negation of it is true. And so when is P or Q false? Well, we answered that. It's both of those components being false. And so you'll go through and answer those types of questions, right? Really thinking about it. So let me go back for a minute. Remember, as I analyzed this, I was wanting the negation to be true, which means the original in parentheses statement needs to be false. P or Q is only false if both P and Q are false, right? That was question number one. And so that's why we came up with that answer. Let P represent a false statement and Q represent a true statement. Well, hopefully remember what that symbol is right there. Sorry, I neglected to cover it up there. I'm sorry, I didn't cover it. I did cover it up, and I apologize about that. But if P is false and Q is true, what about P and Q? Well, P and Q can only be true if they're both true, so this one's false. Should just be a final check in there, and we go through. And so that's what's happening here. We're just going to evaluate statements, right? I don't want to do every problem for you. Now, this one I thought would be good to make sure that we look at. There's something in the video that I made for this that talks about the number of rows in a truth table. And the number of rows in a truth table directly corresponds to the number of statements. In this case, there's 3 statements. There's N, T, and M. Now, things are happening to them, but the statements themselves are N, T, and M. Well, that's 3. And if you remember, it's 2 to the 3rd power, or 2 to however many there are. 2 to the 3rd is the number, let's see, 8, right? Sorry, I had to bring this down in order to do that. And so I put my 8 in there, and I check my answer. It says, hey, let's go to the next question. Now, this one looks crazy. And if you're looking at this, you might think, oh my goodness, I'm not going to know whether that's true or false. Well, they only want to know the number of rows. So we're just looking for the different statements that are there. There's the S statement, the T statement, the U statement, the V statement, the P statement, the Q statement, and the R statement. There's a bunch of statements. I think I counted 7. So our calculator, we got to figure out what 2 to the 7th is, and that will be our answer. Now there are going to be these where we reestablish a truth table, and you may want to do some side work on that. But you're just going to be very patient as you go through here, and you're just choosing whether they're true or false. So construct the truth table for the given compound statement. So we want not P, so that's not P for that first row would be a false, Q would be true, and that's an OR statement. So as we look at the OR statement, you could pull up a truth table and look at it, but we have a false because it's not P, and a true. And a false and a true in an OR statement is always true. The only way you're going to get a non-true statement is that they're both false. So let's look at the next one. Not P is false. Q is also false. So this is false. When P is false, not P is true. Well, the moment that one of them is true, the whole thing's true. And the same with the last one. And so you can go through and get those answers pretty nicely going through there. And then there have an application of De Morgan's law, with some linguistics involved. So let's go back and look at one of those. Just wanted to see what was ahead. Use De Morgan's law to write a statement that is equivalent to the following. It is not the case that pigs can fly or wishes or wings. So that's a not P or Q. It is not the case that pigs can fly or wishes or wings. And so we know that the negation of an or is an and statement of the negations, right, from De Morgan's law. And so the negation of an or statement, like we have here, is not and not. So we're looking for the word and we want both of them to be not. So pigs cannot fly and wishes are not wings. That's that first one. That sounds right. Pigs can fly. Well, that doesn't negate the pigs. So the only way that we're going to negate pigs can fly or wishes or wings is if they're both not true. And we can check our answer. So that's what these later ones are going to be like. And then you have this one here that you'll evaluate whether it's true or false. Right? Just a nice introduction to truth tables. You're filling out one, but really applying the principles of them. So hopefully this video helps.